Hi, Charles Fader here with Hanby Environmental, and I'm with Randy Cook and Jessica Innocente Armstrong with OMG Solutions, and we are going to demonstrate for you the new Total PFOS Remediation Paradigm, where we are going to have water samples that are contaminated with AFFF, that is the firefighting foam that has carcinogen PFOS in it, and we are going to remediate it in real time. We're going to use our Hanby water kit, and we are going to analyze the water sample to see the AFFF contamination level in it, and then we're going to treat it with the ELMN8 Decon, which is the remediation product that OMG Solutions has developed for PFOS. So let's go ahead and create our water samples. We are going to have two samples here made the same way. We're going to use 500 mils of water, because we use 500 mils of water because the EPA recommends that water sample size for doing water analysis, even in the size of a body of water of the ocean. So we use our 500 mils of water. Now that we have our two water samples, we're going to contaminate both of these water samples with the firefighting foam, the AFFF firefighting foam that has the carcinogen of PFOS in it. Okay, so we're going to add 3 drops of the AFFF. 1, 2, 3. Now this water sample. 1, 2, 3. And we're going to cap and shake these water samples so that we can make sure that the entire water sample is fully contaminated with the AFFF. Now, first thing we're going to do is we're going to test one of the water samples to show you the contamination level for the AFFF. Now that we have our PFOS extract solvent in there, we're going to shake that water sample around. And what we're doing there is we're moving that extract solvent throughout the water sample and pulling that PFOS contamination from the AFFF out of the water and into the solvent. Now we're going to decant that extract solvent from the set funnel into our test tube. Up to the scribed line on the test tube. We'll keep it the same. We'll just do the full amount on both. It's fine. We're going to add our color development reagent catalyst powder. Cap and shake. And it may take a few minutes for the color to fully develop.
It's not white.
So as that begins to fully develop, we'll go ahead and move forward with remediating our other water sample as this sits here a little bit longer to fully develop that color. But as we can see, the PFOS is starting to show up. It's not stark white as it was. Like for example, this is stark white. So as you can see there, you can see the color has changed. It's off-white or yellowish. So we'll let that fully develop while we move forward with, we're going to now add the ELMN8 Decon, which is the remediation product for PFOS. We've added one dropper, which is 1 ml of ELMN8 Decon to the contaminated water sample that has AFFF in it, which is the firefighting foam that has the carcinogen PFOS in it. And that ELMN8 Decon is being shook around in that water sample to create the contact of the ELMN8 Decon with the AFFF that contains the PFOS. And as it contacts it, immediately breaks it down. And now that we have done that, we're going to go through by adding our extract solvent to the water sample. And we're going to do that, cap and shake that water sample again around so that we can move that extract solvent throughout that water sample and pull any AFFF with PFOS out of the water sample and into the solvent. In this case, we're not expecting to see any because we have remediated it with the ELMN8 Decon. And that extract solvent separates to the bottom because it's heavier than water. So we're gonna, let it sit for a second to fully separate. Got some air bubbles that are separating right now. You might want to tap it around a little bit too, maybe some. Sometimes you may actually, so we'll go ahead and decant some off and see how much we get. And sometimes you may have to re-agitate it a couple of times to get some more of the separation between the solvent and the air bubbles. The air bubbles have created by the remediation of the ELMN8 Decon remediating the PFOS in this case, or the AFFF. So let's go ahead and decant some off, see where we get. Watching that layer as it decants off, drop toward the bottom. We want to make sure that we don't let any of that through. Okay. Probably want to
a little stir.
Yeah, cap and re-agitate that water sample. You can see we're starting to see some more separation there, but let's go ahead and just re-agitate it and see if we just can't get some more, drop out so it's easier to decant. But in this case, we've already got enough extract solvent in our test tube to do the analysis that we need. As long as you get halfway or more to the scribed line, we're good anyway. But again, just let it separate a little bit. Yeah, you see how we're getting more of it that we can actually decant off. Making sure that stem of the set funnel is dry because we don't want to release any water in there. And then here we go. This should give us all that we need. Okay.
Now, do it one more time?
No, I think we're well. I mean,
sure?
you can see it's even giving you more now. But if you want to, you can.
Yeah, close enough.
Okay.
Okay. So let's add our color development reagent catalyst, the white powder, to our extract. And while she's doing that, I will point out, as we can see here, that the color has begun to fully develop, and as you can clearly see, it's got a nice yellow tint to it. And our result from our treated back to white. And I bring out this calibration here because it actually is a PFOS calibration and show it there. And let's see if I can look at these.
There you go.
Clearly you see the PFOS in the one on your right there that has got the yellow tint, and then the treated back to white over here, which represents 0 or blank. So very clear that the ELMN8 Decon was able to remediate the AFFF firefighting foam that contains the PFOS in it, the carcinogen that is of concern to everybody. So very clearly you can see that we were able to remediate it with these split samples. Thank you.
Thank you.